Good morning, everybody. Yesterday in maths we looked at perimeter, which is the distance around the outside of a shape. Today we're going to look at area, which is the amount of space inside a shape. The way we measure area is in centimetres squared or metres squared, depending on our measurement. My rectangle here is measured in centimetres, so I'm going to do centimetres squared. What that means is how many square centimetres could I fit inside this shape? And we have a formula to help us work that out, which is this. Area equals the length times the width, or A equals L times W for short. So if you ever see this formula, it means area equals length times width. So to find the area of this shape, we've got to multiply the length, which is 2, by the width, which is 5. So the area of my shape here, of my rectangle, is 10. It's 2 times 5. So 2 times 5 gives me 10 centimetres squared. That means that I could fit 10 square centimetres inside this shape. And if we add in our square centimetres, that will make more sense to help you see what I mean. So I've added in my square centimetres now, and you can see that it's 5 centimetres across and 2 centimetres down, which means we can fit 10 square centimetres inside this rectangle. And that's the area of it. The amount of space inside this shape is 10 square centimetres. So as we look through our challenges today, we're always going to remember this formula. Area equals length times width. Challenge 1 says draw these shapes on 1 centimetre squared paper, which you all have in your maths classwork books. And when you draw that on 1 centimetre squared paper, it will help you to see the squares, the centimetre squares inside your shape, and you'll be able to see what we mean whenever we say a shape is 10 square centimetres or 16 square centimetres or whatever. So for shape A, you will draw a rectangle which is 5 centimetres long and 3 centimetres wide. Using your square centimetres, you'll just need a ruler, because each square in your book is 1 centimetre by 1 centimetre, so it's going to be 3 wide and 5 long. Now remember my formula, area equals length times width. I know that the area for this particular rectangle will be 15 centimetres squared. Remember, this little 2 means squared, because 3 times 5 is 15. We'll multiply the length and the width together and it gives us 15. So that's what you've got to do for challenge 1 and the rest of those shapes there. For challenge 2, question 1 says calculate the area of each shape below in square centimetres using the rule. Remember our rule, area equals length times width. Now this time we don't have to draw the shapes in our books or rule the shapes out in our books. We're going to rely on using our rule. So for question 1a, let's have a look at this rectangle. It's 5 centimetres wide and 7 centimetres long. So I'm multiplying them together, length times width, to get my area. And as you all know from your tables, 7 times 5 is 35. So the area of this shape is 35 centimetres squared. We could fit 35 square centimetres inside this rectangle. Once you've worked out the area for the rest of those, it says write the 4 shapes in order of area, largest to smallest, and you can just use their letters to order them. You don't need to write the measurements. Not all shapes are squares or rectangles, they're not all quadrilaterals, and sometimes we need to work out the area of shapes with many sides. A multi-sided 2D shape is called a polygon. An irregular polygon means that it's not a hexagon or a pentagon or those kind of 2D shapes that you would normally see and know. These shapes have lots of sides, but they're maybe not arranged in a way that you would recognise. For example, shape A here has 1, 2, 3, 4, 5, 6 sides, and you know that a 6-sided shape is called a hexagon. So this is a hexagon. It's just not a regular hexagon. which you would maybe expect to look something like this. But this shape has 6 sides, so it's a hexagon. It's just an irregular hexagon. Now we have to find the area inside this hexagon, and there's not really a sum which we can do to help us work that out. So what we're going to do is simply count the square centimetres inside it. And the technique we're going to use is we're going to start with the full squares. So I'm going to count the full squares inside this hexagon, and I'm just going to mark them to make sure I remember that I've done them. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 full squares. Now I'm going to count the rest of the parts, and as you can see in these shapes here, quite often they are half squares. So in this hexagon, this irregular hexagon here, I can see that all the squares that aren't full squares are half squares, which is handy. I'm going to mark them. I've got 1, 2, 3, 4, 5, 6. I've got 6 half squares. 6 halves, 6 divided by 2 gives me 3 whole squares. So my hexagon is 13 whole squares plus 6 halves, which makes 3 other whole squares. So the total is 16 centimetres squared. Shape B is a similar type problem because the squares that aren't whole squares in this one are also half squares, so it's just a case of careful counting. Take extra care when you come to shape C. There are whole squares in it, but there are also squares which aren't whole. Some of them are half squares, but some of them aren't half squares. For example, this little triangle here is not as much as half of a square, and the one beside it is more than half a square, as you can see. But this shape is a little bit like a puzzle. You might be able to spot that if you can imagine cutting this little triangle out, flipping it upside down, and joining it onto this one, the two of them together would make a whole square. So you could count these two together as one whole square. So sometimes these shapes are a bit like a puzzle. Always have a look if it's not a whole square or it's not half a square to see if you can join it onto another one to make a whole. In challenge 2, question 4, we have to find the area of each of the objects below, giving your answer in square units. So it's important to remember here that you give your answer in the units that the object is measured in. For example, the playing card is measured in centimetres, so your answer for that one will be in centimetres squared. And again, remember your formula, the area is the length times the width. Whereas the football pitch is measured in metres, so your answer will be in metres squared. And again, remember, length times width will give you the answer. And we show squared by the little 2 in the top right. So centimetres squared or metres squared. Just be careful whenever it comes to E, you've got to do 8 times 2.5. 8 times 2 you'll be fine with, but just remember that when you multiply something by a half, that's exactly the same as dividing it by 2. So multiplying something by a half is the same as dividing it by 2. Just remember that fact for E.